My name's Steve, I'm the founder and CEO of Roma Batteries. Introducing the Smart 3 range of batteries. This is our third generation of lithium iron phosphate batteries for camper vans, boats and tiny houses. We spent 3 years refining this design and we now have a very well engineered professional products that are designed for high power at 12 volts and 24 volts. I wanted to use this teardown video to show you some of the small little elements that make up the battery, those little differences that show why the Roma battery goes above and beyond to build that best quality battery we can. So the first thing you'll notice is how well packaged the batteries are. Because these are technically class 9 dangerous goods, shipping is pretty difficult, especially internationally. So we've spent a lot of time going through the approvals process to ship by air, boat or by road, and we have full approval and certification to do so. A lot of what you see in the packaging is based around the compliance that allows us to do that. So inside the box, we have a couple of sets of bolts, user manual, safety information, a few little goodies, and this test certificate. This is something that we introduced with the Smart 3 range. We now test every single battery before it leaves the factory. What we're looking for is the top balance, the bottom balance, high load charge and discharge testing, and a few smaller tests just to make sure that that battery leaves the factory in perfect condition. Now you'll notice that the cell voltages across all 4 or 8 cells, depending on what battery you have, are very close together at 100% and at 0%, which demonstrates that the cell balance, the matching of the cells and the build quality is all very high. You'll also see at the top a list of serial numbers, which are traceable. So you can actually reference those, check where the serial numbers, where the cells have been made, when they were made, and trace that from there. That really helps us, but it also helps you get full traceability and visibility of the quality that's inside as well. So looking at the case itself, you'll notice there's a series of little plug holes that go all the way around the side. This is because we've now made the Smart 3 batteries completely serviceable. Inside the battery, which I'm going to show you in a moment, we've pieced together all of the components in a very modular way. Now this allows us to take the battery apart to repair, but also to do upgrades. And potentially at the end of its life, we can break all of the parts down and recycle them for sustainability. So taking the battery apart, very simple. Once we've removed the plugs, we simply unscrew all around. You can see what goes inside the battery. So the battery management system is a custom unit we've had designed for Roma. It's been for a few iterations since we started using it last year. So this provides the standard protections that you'd expect, but also some extras like low temperature charging. We've increased the short circuit protection threshold and we've beefed up the continuous current to 250 amps. So this allows us to deliver a consistent 3000 watts and use pretty much any 12 volt inverter on the market. The switching is controlled by MOSFETs on the second part of the BMS, and they control charging and discharging separately. A typical voltage breakdown of most MOSFETs on a BMS board would be around 40 volts. On a Roma BMS, it's 97 volts. And this is important because we expect our customers to be using our batteries with high power solar arrays. If you're exceeding the breakdown voltage from your solar array and you have a major problem with the solar controller, it's potentially possible for that voltage to pass all the way through to the cells, and that could be a catastrophic failure, would pass through the protections, overload the BMS, potentially cause a fire. So we've specified the safest MOSFETs we can. Next to the BMS is the 2 amp active balancer module. We've also got a QR code on the top here which gives you the serial numbers. That just helps with the servicing of the battery. We've been using this module for about 12 months now on the Smart 3 batteries, and it's worked very, very well. We've got thousands of batteries out there working. The point of a cell balancer in general is to keep all of the cells equalised, whether it's at 0% or 100%, those cells need to be equal voltage. Perhaps you're using a lead acid charger, slightly lower, higher voltage, you're not cycling the battery very often, it's been in storage for a long time. It's possible that those cells can diverge in the voltage, but as soon as you're using this battery, the active balancer is going to bring it back in line. Most BMS use passive balancing, which involves burning off a little bit of energy through a resistor, but because of the nature of that, it's quite low power. If you're charging or discharging at high power, it's difficult to keep those cells in line. Active balancing works differently. It redistributes the energy from one cell to another. It's a bit more complicated, but because it's 40 times more powerful than a standard passive balancing BMS, it can bring cells in line even when discharging at very high currents. So we use grade A match cells anyway, so that means the cell balance is going to be very good when the battery is new. The reason why we add the active balancer, you may not notice straight away, but throughout the course of a battery's life, we're trying to maintain that the battery is going to last as long as possible, get the most amount of cycles and the most amount of usable capacity. Now the power draw of the active balancer is actually very low. It's about 7.2 watt hours per month. So that's pretty negligible. You're basically increasing the self-discharge rate from 3% to 4%, so it's negligible. Strip and pack the pack itself. If you can see, we've used these flexible copper bus bars to join the BMS and the cells to the terminals. This costs more than cables, but they're more resilient, they're less likely to overheat, and they're generally seen as safer. Therefore, we wanted to add these in and improve the overall quality. Now this is important. It's another example of how we've iterated the design of this product. Using these means that we can reduce the heat losses, we can increase the reliability and the safety of the product. So normally with lithium batteries, you would expect to see a pack of cells wrapped in tape, maybe some packing foam, and then hidden away in a glued box. We've designed our batteries to last as long as possible. So this means an engineered steel case that clamps those cells together. So we get the compression, but we also get the protection. Working through, everything has a place, it's secured down to minimise vibration, any potential issues with anything becoming loose over time. Even things like the cables are double protected in fabric and a PTFE conduit. We believe that little differences in quality add up to a big difference overall. When we say our batteries can deliver 250 amps, what we mean is the BMS is rated for 250 amps, but also every other element of the battery is as well. We offer a 10-year warranty, and that's because we fully intend our batteries to last 12, 15 years, and we intend to be around to support customers with that as well. So making it serviceable, making it fixable, allows us to deliver that support quickly and easily to customers. It's also important to us for sustainability purposes. We don't want to throw away a battery for the sake of a faulty sensor. So we make sure that they're as simple and easy to fix as possible. If it's possible to repair a battery, then we will do so. And if at the end of its life, it needs to be thrown away because it's got all of its useful life out of it, it's quick and easy for us to take it apart. We can recycle those cells and we can make sure that we have the minimum impacts possible. So now we've got it broken down to the cell pack. You can see that the individual cells, there's 8 of those in this particular battery, which are 160 amp hours each at 3.2 volts. So we've connected these in a way to make a 320 amp hour battery. On this model, the cells are welded together for security. The balance leads are well protected, which were held together for packing and then clamped together with the steel casing. So this will fit inside the compressed steel case. The tape that goes around here is just for support during construction. So on the cells themselves, you can see the QR code that's on the top there. This is the official serial number. So this matches what's on the test sheet and also on the QR code on the active balancer as well. Thank you very much for watching. This has been Aroma Tech Talk. My name's Steve. If you have any questions, comments, please put them on the video. Get in touch on one of our socials, drop us an email to hello@roma.com or visit our website. Thank you very much.